Welcome back to the shop, everyone. Thank you guys for joining me as we continue to work on this 100-year-old bandsaw. In this episode, I stretch a giant rubber band, make a water snake, and do some wood welding. In case you guys missed it on the previous two episodes, we added a motor, a belt guard, and this really cool, heavy 8-foot tall wheel guard to protect the blade from coming off and into our faces. So we're going to be fitting some tires to these big 36-inch wheels. We're going to be adding some blade guides to actually help the blade go where it's supposed to go. And then we're going to be adding a counterbalance system to help raise and lower those guides to accommodate different material heights. So that's a lot to do to get this machine running, but I think we can accomplish it. So let's get started. So the first order of business is to install this ugly tire that replaces the old one that's been basically falling apart. And sheesh, I bet you this is probably the original tire that's on here. It's pretty incredible. But the idea of this big rubber band is to make this machine quieter, make it smoother running, and it protects the wheel from the set in the tooth. We're going to be stretching this tire over these wheels, so there's really no use for adhesive. But if the tire doesn't stay on, we can apply with some contact cement or some special glue to get it to held on there. So let's get the tire put on here and get this wheel a-turning. I'm not quite sure why they sell these tires in orange. I would have rather had black, but if it bugs me too much, I'll source another set if I can find some. The best tool that I found to remove the old rubber was just a simple carpet knife and a wire wheel to clean up the residue. Whew, glad that project's done and over with. That was way more work than I thought. Stretching this rubber band over this big wheel, you can feel that's like stretched pretty tight. Moving on, what I need to do is get some blade guides mounted on this machine. I don't have the originals, so the next best thing is just to buy some. This is a toolless design guide. All you need to do is adjust the thumb screw. These are a little bit light duty for the saw, but since I'm only going to be running most of the time like a 3/8 wide blade, this will probably suit my needs just fine. So we're going to retrofit these ones off of another machine onto here. And as you can see, look how far off this guide fits. And we got to grab onto this post, and this post goes up and down. So that's the problem, is getting these new saw guides onto this old machine. As you can see, we got to do the bottom and the top. So let's get to it. I want to make a base plate to mount the guide to. I started with a picture and inputted it into CAD. From here, I could easily let the water jet cut it. I decided to do it the old-fashioned way and print out a template. And from there, I stuck it to the plate as a pattern. Any method of cutting is pretty acceptable, but I chose to use the bandsaw. And once again, I'm faced with the problem of measuring the casting of the saw and using the existing original holes. I just got my drill press fixture plate installed. This really helps with increasing the capacity of the table size while making it easy to clamp everything down to. If you guys would like to upgrade your drill press, I'll leave a link in the description below. To attach the lower blade guide, I made this cool funky bracket, and it attaches to one of the bolts on the machine. So I need to do some welding on this bracket, because I want to add a gusset and a shelf. So I started off with some magnetic shims to place the minion square on top of it. This helps clear the roll from bending the material, and then I'm able to fasten the gusset to the minion square. That way I know it won't move, and it'll keep it perfect as I'm welding. The bracket's going to give me some flexibility to move the saw guide up and down and in and out. So I'm ready now to tackle getting this upper blade guide installed on the machine, and I've been really contemplating how I'm going to do this. So it just so happens a long-time listener, first-time caller sent me an email of, look at this, an original guide for this saw. Remember, this saw was made in 1890 to 1911, so finding something that's original to this saw is pretty amazing. So thank you, Mike, for sending in some drawings. And what I noticed is that there's a tapped hole on the bottom of this column for the guide support, and I'm going to be taking some inspiration from the original guide but kind of retrofitting it to this new style chintzy little guide. Because I'm running out of time and I need the saw working, I'm going to use these guides. But for now, here's my ideas on how I'm going to tackle mounting my guide to the saw. So my idea is to water jet out a bracket that's going to fit the profile of this bar and extend it out the distance that I need to pick up the blade. But here's a problem. The center line of the blade and where it rides on this bar is about there. This bar is physically twisted, so it's not sitting square with the way the wheels are and the way the blade sits. So if we were to project the flat face or the side out, it's gonna like come out here. It's not even in line with the saw blade. So we're gonna have to come up with something clever to get the twist out of this column. So as you look at the way this guide is supposed to be installed, that pin is like over here. So what I'm going to do is I think I'm gonna cheat and I'm gonna flip this guide upside down. Now that just brings this wheel lower, and I don't think it's going to affect the saw blade that much, but what it does is it puts me more in line with this bar. So I'm going to flip the guide over and give it a try. Plus I'm right-handed, so being able to adjust these quick adjust will be a little bit easier for me also. So that's the plan of attack, so let's get that going. Taking two pre-engineered parts and trying to bridge them together is always a challenge. I would have really liked to made my own set, but time just wouldn't allow, but maybe we can revisit making some guides at a later date. I milled a shoulder at the angle to match the twisted support bar. The shoulder will also prevent the bar from twisting as it's mounted to the column. Holy smokes, that was a little more work than I anticipated, only because of the design challenges that was set before me, because we had a constant with the saw and then a constant with building off of somebody else's saw blade guide. So let me take you in close to show you what I did and why I did it. I put a curve in it on the water jet to make it look like an actual part and not a piece of bar stock that we just pulled off the shelf. But overall, the challenge was getting this piece of bar at the lowest point to be at the lowest point of the saw guide. And I do have this guide upside down. I think it'll work just fine in this configuration. It saved me a ton of time orientating in this position rather than where it should be. I can control my in and out on this 5/8 diameter pin. This will change according to what thickness of blade or the blade width that I'm going to be using. And then these little guides actually are pretty nice with their little thumb screws to be able to quickly adjust from blade to blade if I so choose. And then you can just lock it down with this cool handle. And of course I had to do some bluing on it because I didn't like the shiny finish what we're going with the saw, so this kind of makes it blend in a little bit differently. And then I do have a slot on the bottom of the slide here so I can adjust for side to side, because if you can't make it perfect, you make it adjustable. If we want to choose to change it later on, we can easily do so and it's not that big of a deal. But in the meantime, let me take you around back to show you the next problem. The next feature that I want to fabricate is a really cool counterbalance system that a lot of these old saws had when they were made, but unfortunately this one is missing. And the idea behind it is that this whole system, when you want to raise or lower it, weighs 12, 13, 14 pounds, and it's pretty heavy. So the original design was a pulley over here and a pulley over here. Then they strung a cable up and over those two pulleys and added a counterweight that matched the weight of this whole system, therefore giving this a floating effect and basically taking very little effort to raise or lower this. Using some small pulleys like was on the original would be pretty cool, but I want to be a little bit more creative and put my own twist on things. So I want to add some big giant like 10 or 12-inch wheels to this beast. I think it'll look really cool when it's all done. The first thing we need to do to get this wheel mounted to the machine is build some sort of bracket. And I've come up with 3, 4, 5 different styles that I've liked and didn't like, but eventually deciding on something that's 10% function and 90% art. This is the bracket that we're going to use to mount the wheel to the machine, and it's going to find its attachment point on top of this flexure on the top, and then we're going to have to make some sort of cool S-curve to avoid the oiler on the top, and then it's going to make its way down, and I'm going to have to build some sort of clamp to grab the snout. And then just for good measure, because I think it looks cool, is this saddle that we're going to mount on the machine, so this high heel of this bracket can sit on it. And then we have a hole here to mount a shaft to put the wheel on. It's pretty basic, pretty simple, but overall I think it's going to look really cool when it's done. So let's go cut it out and get it installed. For this clamp, I had the water jet cut me a 5-degree angle on the inside dimension. This is to match the draft angle in the existing casting, and this will also save me a ton of time of grinding to match the profile of the machine. It'll be really good to have this clamp here too, that way if I do want to add an accessory later, I have a place to mount it. Some of you guys have asked me what is going on the backside of the cut. So I raised the plate up here to show you guys what it's actually doing and still how powerful it can be. I really like the way this bracket turned out. All that thoughtful pattern making and design really turned out nice. The oiler port on the top is still exposed, so I can get to it. The sweeping curve at the top adds another whole element of style to this saw, and this extra clamp on here is because I wanted a cool challenge. But overall, we got a great target to mount the wheel to. Now it's time to get wheel number 2 mounted, and it's gonna probably sit in this general vicinity right here. It's kind of my thoughts. Now the easiest thing to do to get this wheel mounted is to probably build some brackets off this hinge bar right here and hang it down over the side, but that's just way too easy. And this is the Fireball Tool channel, and we like to make everything way more complicated than it has to be. So my new idea is to give this cool machine some iron lace. And it's gonna wrap right around her midriff right here, and kind of taking some inspiration from the sawtooth, triangle, and some of the finials on the top here, and kind of give her a bracelet or a waistband, something that's kind of, I don't know, challenging and fun that I've never done before. But let's see if we can wrap one big giant piece of metal all the way around her and tie it back, and that way we can have an attachment point for the wheel. This may look good, this may look ridiculous. Let's see what we come up with. This section of the saw is actually kind of tricky. You have some taper going from thick to thin as you climb up the top of the spine, and also an arch built into that whole thing. So the use of CAD and some CAD board definitely makes things go a little bit smoother. Cutting the metal, I knew I didn't have to be too perfect because I was going to use heat, and it's going to offer me a lot of flexibility to push, bend, pull this whole lace all the way around the machine and then tie it together. I really enjoy doing metal experiments like this. I find by going off the beaten path, trying something new, I learn a lot more about myself and how to manipulate metal. Take a look at how cool this bracket turned out. It actually turned out better in person than it did in my mind. And it was so cool that I just couldn't wait. I just smeared some cold blue all over it just to see kind of what it would look like if it was finished. And I'm kind of leaning towards this look on everything. And it's appealing to my eyes, which I like. But the wheel's gonna sit right here, so this little extension piece is where the axle's gonna go into, and you won't even see any of this. But I think this is a cool addition. And I learned something along the way, and that's what building things all about, trying stuff that's new. We need to build some wheels, so let's head over to the water jet and cut some wheels out. I envision building this wheel kind of like a puzzle, with many interlocking pieces. So in order to cut this wheel out, I'm going to be using the water jet, and it's going to be cutting this 1 13/16 black walnut wood. And with these segments, I'm going to tie them together with a connection that I'm going to be calling it collar and tie, and it's kind of this joint that I'm coming up with that I think looks kind of cool. But we're going to cut all the pieces out, and then we'll come back and glue them together when the water jet's done. Cutting the wood on the water jet is really fast. The water really doesn't have enough time to soak in, to swell up the wood, and the segments were dry in about 15 minutes. I got all the wheel parts cut, so let me bring you in closer to show you my idea on how this wheel is going to assemble and go together. Let's start with the water jet cut blocks. These are going to lock together with this different type of wood joinery, and man, I could literally have a YouTube channel on just water jet and wood joinery because the possibilities are literally endless. But you're going to have an alternating pattern, and we're going to lock them together, and you can see how nice these parts just fit so perfect. One little squeeze and those parts are not coming apart. I will have to destroy it to get them separated. That's how tight they fit. And when they're together, they look something like this. Here's a sample piece that I did. So you can see how tight the joints fit with no glue or anything added in there. So that's how the joints are going to look when they come together. And I don't think that this joint quite fits the look of the machine. So what I'm going to do is kind of distress this joint a little bit. And I'm going to do that by adding a little bit of flame around this joint. And what that's going to do is going to burn the edges away a little bit and kind of round the corners and make it not look so perfect. And kind of add another little bit of depth to each joint. And then the spokes to hold the wheel are going to be these little funky things. And what's going to happen is I'm going to drill a hole. Here's a test sample of a little rib in there, and then they're just going to stab themselves into the hole, and then generating all the spokes will get tied together with this ring, and we'll either choose to bolt it, rivet it, or do something clever, and we'll have a ring on both top and bottom. And then this leaves me a bore to be able to put a bearing or some sort of journal bushing in there to spin around and around and around and around. So that's the overall construction and idea. So let's go to the milling machine and we'll drill some holes in all these parts and start fitting and filling the whole thing together. It's not every day that I get to make a wood wheel, so I took this opportunity to make something that really stands out. I think it looks better than something that was cut from one piece or two piece, and the segments just really do add a whole look and style of their own to the whole machine. With some brown dye to add some authentic old look to it and some blue bits, I really think the wheel is looking amazing. Then I made another wheel with the exact same construction as the first, but just a little bit smaller this time. I really didn't like the thin spokes that I had originally designed, so I went ahead and changed them for a similar 1/2 inch thick spoke. Now that I got the wheels all sorted out, now time to get them attached to the machine, and I'm just going to build an axle that comes off this bracket and into the hub. So let's build the axles. Since I've gone crazy on this wheel so far, I thought I'd add some roller bearings. keep the wheel looking as authentic as possible and to hide the roller bearings, I copied the nut from the big wheels on the front of the machine. Take a look at how cool these wheels turned out. Overall, I'm extremely happy with the overall look and feel of them. And I do have to say, the guys who make movies to make things look old, I definitely give them props, because turning some brand new, nice shiny wood, cutting it with a precision instrument, then having to make it look old of this era is quite a challenge. But I think it kind of fits the overall machine, and I learned something by doing it. The next step we gotta do is get these wheels attached to something. We're gonna need a weight on this end and then attach it to the saw guides on the other. So that's gonna be our next challenge, so let's get to it. I weighed all the parts and they came out to be about 16 pounds. This is gonna be my target to make the counterbalance. The water jet here in the shop is a huge time saver. It took 4 minutes and 30 seconds to cut out each disc, and when you think about doing this on a manual machine, by the time you slice up a shaft, then you put it on the lathe, and then to the milling machine, there's no way I could do that in 4 minutes and 30 seconds. I envision some leather going over the wheels, so let's get some leather cut. Now, this is the payoff. Watch how easy this is to move. Man, I mean, it's just with my little finger up and down. There's at its highest point, and there's at its lowest point. This 16 pounds of weight just feels maybe like 1 or 2. I think it looks really cool. What do you guys think? Tell me in the comments, did I go crazy? I don't know, I think it's worth it. Now what I have noticed is that the belt is staying right where I want it as far as tracking goes, but if I need to come back and put a little groove into the face or the surface of the wheels, just to add a little extra protection to keep the weight from falling off the end or this from slipping off if somebody bumps it, I'll probably go do that off camera. It's pretty simple, but man, I think it looks great. I find it extremely challenging to make something look old when I want to make everything look perfect and new and shiny and clean, and it just kind of goes against everything I've been trained to do. But that's why I enjoy trying something different on a piece of equipment like this. So hopefully you guys are learning something like I'm learning something. We got a little bit more and we're on the home stretch to getting this machine running. So I'm going to sit here and play with this cool contraption, and I'll catch you guys on the next one.